Okay, so we're going to pick up where we left off. So the last thing I said was we're going to show those two triangles are similar by angle-angle postulate using a flowchart. That's what we need to do. Okay, so first one, where's my black marker? Oh, no. Oh, there it is. Okay, I'm going to create a flowchart first. Oopsie, wrong way. All right, so let's see, we have a couple of things that we need. First of all, if it's angle-angle postulate, we only need to show two angles are congruent. You can show all three if you want. I'm perfectly fine with that. But I'm just going to show two. So I know angle A is equal to 35 degrees. I know angle A corresponds to angle E is also equal to 35 degrees. Oh. Okay. This is going to be a little tricky, so you're going to have to bear with me here. So that means that angle A is congruent to angle E. That's the first one. And then the second one is angle D is equal to 35 degrees. So angle B is equal to 35 degrees. And then that means angle D is going to be congruent to angle B. Okay. This is going to be the only time where I can honestly say it doesn't give you something, but I'm going to pretend it did. I'm just going to go with it. I'm going to say these are givens, but they're not givens. Shoot. The only one that was a given was angle D, so I'm just going to do that. Okay, angle D was the only one that I gave you. You had to find the rest of them, and you did that by finding or by remembering number one, that angle E was also 35 because of base angles, right? So I'm going to say, well, based on base angles theorem, because you knew, since this was an isosceles triangle, that angle D and angle E had to be the same. So you put 35 degrees down, you have to give me another reason other than given, and the reason was because of base angles theorem. Okay, angle A was 35 degrees because you had to split A and B up from 100 because it had to all equal to 180 degrees. So I'm going to say angle A and angle B are both 35 degrees for kind of the same reason, the base angles. Okay. So base angles theorem. If you didn't remember the base angles theorem, the other way that you got the 35s and the 35s and the 110 is by knowing that either it was isosceles triangles, you can say that, or you can say that you added them all up to equal to 180, and that's the triangle sum theorem, SUM theorem. So you only had one given. Okay, that angle D was equal to 35 degrees. Okay, the next one is, since they're both equal in measure, then they're both congruent to each other. That was your definition of congruence. Same thing here, definition of congruence. Okay, and then lastly, these two triangles are similar by angle-angle. These two triangles are going to be similar by angle-angle similarity. That was one of the ones we said if you can show at least two of the angles are similar, then the third angle by no choice, I should say, is going to also be the same. So we only really need to show two to be sufficient. So triangle, what did we need to show? Triangle ABC is going to be similar to triangle ABC, EDC. By angle-angle similarity. And then the next question was, well, Sherry and Robertson noticed that similarities to part B are not the same. She said that this one was this and that one was the other one. Who is correct, or are they both correct? Explain your reasoning. So you have to decide. I kind of like the way that I did mine because I'm kind of going in a specific order. I don't think the other one's wrong. I don't know. I have issues with that. So ABC is congruent to EDC is kind of how I want it to kind of how I want it to write out. 105 is the next one, I think. Okay, Natalie has a bag that contains 8 marbles. She draws out a marble, records its color, and puts it back. So you don't know how many colors she has in the bag. You don't know if half of them are yellow, half of them are pink. You don't know if there's literally 8 different colors in there. All you know is that she repeats it 8 times and does not record any red marbles. Can she conclude that there are not any red marbles in the bag? And then explain, it says, is it possible that she drew the same marble every time? It is, actually. There is if she puts it back in, then yes, there's a possibility that she may draw the same marble every time. It's a very small possibility, but it does exist. And if it does exist as a possibility that she's picking up the same one 8 times, then, you know, can you conclude that there's not any red marbles? And the answer would be no, you can't. All right. Now, if she repeats it 100 times, does not record any red marbles, can she conclude there are not any red marbles in the bag? Explain. And they didn't really give you a hint on this one, but I can tell you it's pretty much the same thing from the one above it. It could possibly be that she's picking up the same marble every time. Unlikely, you know, but you don't know. So if you don't know, there still might be a possibility that there could be a red marble in there. It's very small, especially if you're picking it 100 times, but it could still be there. How many times would she have to draw the marbles, putting them back each time to be absolutely certain that there are no red marbles in the bag? Answer C. No number of trials can absolutely prove that there are no red marbles in the bag. No matter how many times you do it, there's still a slight possibility that there could be something red in there. Alright, so that was 105. So there's really not that much math that goes along with it. And then the last one, 106. Like I said, I'm skipping 104. You can do that one on your own. 106 is, which equation below has a graph that is perpendicular to y equals negative 2 over 5x minus 5 and passes through point 4, comma, negative 1. Okay, I do not encourage you to skip this problem because it will pop up again and again because we're going to start doing linear stuff a little later. So the first thing that I will remind you is if something is perpendicular to something else, then their slopes have to be opposite and reciprocal. So if you have a line and it has a negative 2 over 5 slope, its opposite and reciprocal slope should be, the perpendicular slope to your original line should be equal to 5 over 2. It's flip the numbers, change the sign. And you want it to pass through the point 4, comma, negative 1. Well, if that's true, then you can just plug it into y equals mx plus b and find out what your value or what the equation is of your line that is actually perpendicular to the other one. Let's see, y is negative 1, your slope is 5 over 2, your x value is 4, you plug it in, negative 1 is equal to, put it over 1, this is a 10, minus the 10 on both sides, so you get negative 11 is equal to b. Okay, so your new line is going to be y equals 5 over 2x minus 11. Okay, this is your perpendicular line. The question is, which one from A through D is actually the same thing as 5 over 2x minus 11? I'm not going to go through all of them, but the process is the same like how I'm going to do part A. A says that 2x minus 5y is equal to 13. Okay, well, it's not in y equals. You have to find the one that matches the one that I boxed up, 5 over 2x minus 11. So the way that we do this in Math 1 is we subtract to get the y value by itself. So now we have negative 5y equals 13 minus 2x. Divide by negative 5. Divide everything by negative 5, I should say. And if this is starting to look a little familiar, that is good. 13 over negative 5 plus negative 2 divided by negative 5 is a positive 2/5 x. But it doesn't match what I boxed up. So now I know that A is not my answer to a line that is perpendicular through my given negative 2 over 5x minus 7, and it passes through this point. So you got to find B, C, and D. You have to do the same process that I did for part A to find out which one it is. And please check all of them. Just because one of them works, that doesn't mean there aren't more. Okay? Even though it says multiple choice, just check. You need the process and the practice of it. Okay, I'll see you guys tomorrow.